For as long as we've been human, we've looked up at the night sky and just wondered, what's out there and what's our place in all of it? Well, today, we're going to dive into that incredible story. We're going to trace our journey of discovery from ancient myths all the way to modern science to really understand our home, the solar system. And that right there, that's the big question, isn't it? It's the one that fueled centuries of debate and mind-blowing discoveries. This is a story about completely flipping our perspective on the entire universe. Okay, so let's rewind way, way back. Long before we had telescopes, ancient civilizations were already astronomers. They saw the same sun, the same moon, the same wandering stars we do, and they came up with these brilliant, elaborate stories to make sense of that cosmic dance happening above their heads. So you can see just how much our thinking evolved. For more than 1,000 years, the geocentric model, with Earth right at the center, was pretty much accepted fact. I mean, it makes sense from our point of view, right? Everything seems to go around us. But then, 1543, Nicolaus Copernicus drops this bombshell of an idea. What if the sun was at the center? That one question kicked off a scientific revolution that changed literally everything. And that brings us to where we are today. We now know we live in a heliocentric, a sun-centered, solar system. And the star of this show, both literally and figuratively, is of course the sun. The sun isn't just some big light in the sky. It's the anchor for the whole system. And that third point, get this, it contains 99.8% of all the mass in the entire solar system. Everything else, all the planets, moons, asteroids, everything, is just the leftover 0.2%. It's that incredible mass that gives the sun all its power. And that power has a name, gravity. You can think of it like an invisible string that ties every single planet, from tiny Mercury to giant Neptune, directly to the sun. It's what pulls them into those stable, predictable orbits. Without gravity, they'd all just fly off into deep space. So our solar system really has two totally different neighborhoods. You've got the inner planets, the small, rocky worlds like ours, all huddled close to the sun. And then, way out past the asteroid belt, you have the giants, the massive gas and ice worlds. They're like two completely different families living in the same system. All right, so with our sun-centered model locked in, how about a quick tour of the neighborhood? Let's start right next to the sun and work our way out. It's time to meet the family.
Right up close to the sun, we've got the rocky planets. There's Mercury, the little speedster, zipping around the sun in just 88 days. Then you have Venus, a truly hellish world with crushing pressure and clouds of sulfuric acid. Then, of course, there's us, Earth, the only place we know of with life. And rounding out the inner circle is Mars, the cold, dusty red planet that we're so curious about. Now, once you cross the asteroid belt, you enter the realm of the giants. And the first one you meet is the undisputed king, Jupiter. This planet is an absolute beast. It's more than twice as massive as all the other planets combined. And that famous Great Red Spot? That's a storm wider than our entire planet that's been churning for hundreds of years. Just incredible.
Next up is Saturn. And honestly, it's probably the most beautiful planet in the whole system. Those amazing rings aren't solid, They're made of billions and billions of individual pieces of ice and rock all swirling in this huge flat disk. It's no wonder they call it the jewel of the solar system. Finally, way out in the cold, dark fringes, you find the two ice giants, Uranus and Neptune. They get those gorgeous blue colors from methane gas in their atmospheres. And Uranus is the real oddball of the family. Something long ago must have knocked it over, because it basically orbits the sun spinning on its side, like a rolling ball. Okay, let's zoom back home for a minute, because the relationship we have with our moon is it's incredibly special. Its gravity acts like an anchor, keeping our planet from wobbling all over the place, which gives us a stable climate and predictable seasons. It pulls on our oceans, creating the rhythm of the tides. And in what has to be the most amazing cosmic coincidence, it happens to be just the right size and distance to perfectly block out the sun and give us a total solar eclipse. And the moon itself? It's this silent, incredible world. It's covered in craters from billions of years of getting hit by asteroids and comets. And since there's no atmosphere and no weather, nothing ever changes. The scars never heal. It means that every single footprint the Apollo astronauts left is still there, perfectly preserved. It's like a museum on another world. So, beyond the main planets, our solar system is buzzing with other, smaller objects. We've got icy wanderers, fiery streaks in the sky, and, well, one very famous celestial outcast. Okay, people mix these up all the time, but it's actually pretty simple. A comet is basically a big, dirty snowball that grows a glowing tail when it gets close to the sun. A meteor is that flash of light, the shooting star, that you see when a piece of space rock burns up in our atmosphere. And if a piece of that rock is tough enough to survive the trip and actually hit the ground, then we call it a meteorite.
All right, let's just get to it. This is the question everybody asks. Pluto was a planet for 76 years. What on earth happened? Why the demotion? Well, the answer comes down to science getting a little more specific with its definitions.
So in 2006, astronomers came up with this 3-point checklist for what makes a planet a planet. And as you can see, Pluto nails the first two. It orbits the sun. Check. It's round. Check. But it fails on that third rule. Its neighborhood, its orbit, is full of other icy objects out in what's called the Kuiper Belt. It hasn't cleared its path. So it got reclassified into a new category, dwarf planet. The thing is, our understanding of the solar system isn't some finished book on a shelf. It's a story that's still being written. And every new mission, every new piece of technology turns another page. Just think about it for a second. Galileo points a simple, early telescope at Jupiter and sees moons orbiting it. And that one observation helped shatter the old Earth-centered model. Now, today, we have things like the James Webb Space Telescope doing the exact same thing, but on a scale that would have been unimaginable just a few decades ago, revealing secrets we never even knew existed. I love this quote from the astronomer Edwin Hubble. "The history of astronomy is a history of receding horizons." It perfectly captures it, right? Every time we answer a question and we think we've reached the edge of our knowledge, that horizon just moves further away, revealing a whole new set of mysteries to solve. So that's where we are. Our entire map of the cosmos has been completely redrawn before, and you can bet it's going to be redrawn again. Which really makes you wonder, doesn't it? What amazing discovery is waiting for us just over that next horizon?